Good morning everybody, myself Acharya Vishvendra, and today I am going to discuss a worksheet on the position of the center of mass. So let's begin with the worksheet. So here is the worksheet. So the first question is position vector of center of mass. So suppose the system is composed of n point masses having position vectors r1, r2 up to rn. So the position vector of center of mass is m1 r1 plus m2 r2 so on up to mn rn upon m1 plus m2 plus so on up to mn. This is the first expression. Similarly, we have result for XCM, just replace R by X, so we have this result. Similarly, for YCM, replace R by Y, and for Z, replace Y by Z, and we have all the corresponding results. Next question is, three particles have masses 2 kg, 3 kg, and 4 kg respectively. Their position vectors are 2i plus 3j plus 4k, I plus j plus k, and 3i plus 2j plus 4k. And we need to find the position vector of the center of mass. So using m1 r1 plus m2 r2 plus m3 r3 divided by m1 plus m2 plus m3, we have RCM as 19 I cap plus 17 j cap plus 27 k cap by 9. Now if we see for I cap the coefficient is 19 by 9, so XCM will be 19 by 9. Similarly YCM will be 17 by 9 and ZCM will be 27 by 9, which will be 3. Next we have 3 point masses at the vertices of an equilateral triangle, and we need to find the x coordinate of the center of mass. So this and this vertices is at the origin, so using m1 r1 m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, we have after all the calculations as 7 L by 12. Next is YCM. So similarly using the concept for YCM, we have L by 4 root 3, and ZCM will be 0 because this is in the xy plane. So Z coordinate of every point is 0, so that means ZCM will be 0. Next is position vector of center of mass. So that will be 7L by 12y plus L by 4 root 3j. Next is we are being given a square, and some masses are placed at the corners of the square. The first question is XCM. So using m1 x1 m2 x2 m3 x3 m4 x4 by summation of the masses, we have x center of mass as a by 2. Next is y center of mass as 7a by 10 using the same expression. Then is the position vector of center of mass as a by 2 I cap plus 7a by 10 j cap. Next is 4 point masses are placed on a circle, and the first question is we need to find XCM. So using m1 x1 m2 x2 m3 x3, we have XCM as r by 5. Similarly YCM as minus r by 5, and position vector of the center of mass as r by 5 I cap minus r by 5 j cap.